Okay, thanks everyone. So it's really great pleasure to be here and share about this topic. Now I have to say this is the first time this year I came to NTU, but because of the charisma of Vitalik and probably our Professor Wen, a trip from SMU to NTU becomes just a piece of cake. Now it's really great to see such a great audience, and it's also my pleasure to talk about this topic on AI and Web3, almost the two most sexiest word of today's topic. Now, I know it's very hard to actually prepare for the talk for this audience because I know some of you are beginners in this area, but some of you are really veteran developers in this domain. But what I try to cover today is, first of all, I want to give a very broad view about the current status of AI, as well as why Web3 is so important for the governance of AI in this age. And then I want to show you a couple examples for application of this Web3 in this AI domain. One of them is about fighting misinformation online, which is a national task force. The second one is using Web3 for decentralized federated learning for B2B business data sharing. The last one is on how to establish personal data as an asset. All right, so let's start. So how to get, sorry? Oh, okay. All right, so let me just give a very, very brief overview of the history of AI. Actually, I think most of us have been in this area for long, so we know. But as I remember, when I started learning about data and AI more than 20 years ago in my PhD days, what we focus on really is on what we call pattern matching. It is for looking for specific patterns in the data with very clearly defined, for example, pattern of substrings, pattern of images, and some pattern of phrases. And then the code we wrote at that time only would work for a very specific problem domain. And then if you look at what happens 10 years after that, people start to train models to look for solutions. So we tend to develop models not to look for just a particular pattern, but really to solve a class of problems. So for example, my PhD has been working on so-called large graph model learning. So we're trying to find patterns, in particular distributive graph patterns in large networks. And then nowadays we have neural networks, right? We know that with this type of model, we are able to solve what we generally call artificial general intelligence. And here came ChatGPT. Oh, sorry. So according to McKinsey, the ChatGPT and the AIGC has really greatly improved our, not only the use case in terms of this economy, but also, for example, in the productivity enabled by this general AI. So on all the existing analytics, right? This is our existing analytics. Just look at the generative AI use cases. There's going to be a 15 to 40% increase on top of that. And if you count in the worker productivity enabled by the generative AI, then there is going to be a 25 to 70% increase, right? That is really something huge. Not only that, if you look at the business functions that has been enhanced by the AIGC across all the different domains, of course, high tech, banking, education, we know that. But interestingly, if you look at healthcare insurances, all these industries has benefited hugely from the use of generative AI. And of course, just now, Prof. Liu Yang shared about all the generative AI usage in software engineering. Naturally, for example, you see software engineering. Here we have the darker colors. But another very dark column here is actually in marketing and sales, as well as in, for example, customer operations. And it has fundamentally changed many industries. For example, recently when I talked to some senior managers in our banking industry, they said that they have been deploying AIGC and the ChatGPT in their customer relationship management. Why, generative AI is so special, right? I think besides other things, one of the very important things is because of interface. If you look at history of computer science development, I remember when I was a kid, we use, we use a command line, right? We use DOS. We type in command to operate things. Then we had Windows, where we actually can operate computer with a visual interaction. And now, instead of search, we can actually chat with computers. That is a great step because it really brings computer closer to everybody's life. So I think the reason why now ChatGPT becomes a phenomenon, one of the biggest reasons is because of this interface. Now, if you're in the AI domain, we actually knew about ChatGPT quite some time ago, right? I think 2 years ago, we know this GPT thing is coming, but nobody actually expected it to be so powerful. To be frank, even OpenAI, before March last year, nobody expect actually ChatGPT will be so powerful. And we actually tried using that, the early versions. It was not that impressive. However, somehow it just worked, right? I mean, if you check to, I don't know if you have talked to Sam last time when he visited SMU a couple months ago. He admitted that, nobody expected that what they are developing to be so powerful. But somehow it has this so-called emergent phenomena. Sorry about that. Something is emergent phenomena. And because of that, the algorithm, the ChatGPT, can actually perform something that is not originally designed for it. Okay? So of course, that's not the main thing we want to talk about today because we know how wonderful these things are. The main topic thesis that I'm going to argue for today is that the more powerful the AI, the more important that the governance is, right? Because, ChatGPT is not capable of really governing where the direction AI is going. And this is by no means a complete list of all the issues that people identify for today's AI domain. For example, people start to talk about the decentralization and democratization of these large language models. For example, OpenAI is charging $19.99 now per month for using GPT-4. What if it charges $29.99 next month, right? We're going to pay for it. What about $49.99? If your whole business is built on top of ChatGPT, you cannot afford that one day ChatGPT stop operating, right? So at least can we have an alternative that we have a decentralized ChatGPT so that nobody can power off, right? In this case, how are we going to allow democratized access to this large language model for everyone? And then how to allocate the profit and revenue when you contribute data, machine, and computational power to this decentralized ChatGPT. The second issue is that right now, the data transactions, the dialogues we have with ChatGPT is not transparent, right? We cannot verify how our data has been used and who has been using our data. Now, last time when Sam was on SMU campus, people asked him whether ChatGPT actually stored clients' data and how clients' data has been used. Now, of course, his answer back then was that ChatGPT would not actually store your data. But we also see cases where people sued ChatGPT because of the misuse of their data. So everything is not transparent for now, right? And then, what about the profit allocation, right? In the future, if let's say we have an open source and decentralized ChatGPT where universities, researchers, or government agencies can collectively compute something, then if you contribute your proprietary data, right, you contribute your models to ChatGPT, you would expect some fair allocation of profit according to your contribution. And we need a mechanism to decide how to reward people in this way. And finally, in later example, you're going to see nowadays we have to pay a lot of attention to so-called data provenance, where data come from, where data goes to, and how data flows through different models. Because we have to hold the model accountable in many situations. Just now, we talked about in the vehicle network, right? There are lots of issues where whenever there is a problem, you have to check what exactly went wrong and who we should hold accountable. So one phenomenon we're seeing that the competition now is shifting toward computational model to proprietary data. Previously, companies compete whether your model is better than my model. Now, if most of the SME are going to realize that your model is not going to be able to compete with ChatGPT. So everybody ends up trying to find out whether you have your unique business data, right? And if you let's say hospitals, they are using their proprietary healthcare data and hospital data to form an alliance, and then use their data to train a customized health GPT, right? This is a new business model. So the competition now is gearing toward, again, establishing data and asset. And this is our focus today. But unfortunately, if you look at the current day data ecosystem, there are lots of issues, right? Because if you look at the view from different parties, right? Nowadays, if you look at the data, right? Data could come from the individual, data could come from business, data could come from the government. And these arrows indicate the direction how data flows. And there are lots of issues in each of these directions. For example, if you look at when data flows from individual to business, right? This is our most familiar cases. And we're seeing that nowadays the value allocation is very unfair, right? Each individual contribute almost all the data to these social platforms, to these business applications. However, you don't get a single cent from what you contribute. And secondly, the control of data is very weak, right? Nowadays, it's very hard to choose whether you can opt in and opt out of certain services. And can you actually delete your data from the platform? Are you sure when you delete, it's actually being deleted, right? And not to mention that there are issues, there are many things. There are many issues about, for example, challenge to privacy, right? We have heard too many stories about that. And of course, when individual data flows to government, for example, for the last couple of years, we have traced together, right, collecting everyone's data. And, you know, people are asking where these data go to and how the government is going to use these data. And the last but not least, when data is trying to flow between business or between government agencies, there are lots of issues, for example, like data isolation or so-called data wars. Another perspective is let's look at the data ecosystem, because if you want to bring out value from data, you cannot just use raw data, right? Data has to go through model and to be used in applications. But if you look at who owns each component, right? The individual users own the data, but users does not have access to model and application. But who has access to model? Computer scientists, professors like us, right? We write papers every day and then we publish results. But it's very hard for us to get access to real users' data. All right? I remember almost for my whole PhD days, I've been using this so-called DBLP data, right? Because it's the public data and open accessible data. So we don't have access to very high quality user data as we wish. And then at the same time, it's not very easy for us to actually apply a state-of-the-art model in the real business application scenario. Why? Because it's not easy to convince business to adopt our solution. The best thing I can do is I can send my student, for example, to the company to do a 3-month internship, for example, right? And then who has the application? The business application. But then the business usually don't have access to the data that they want to know the customer better. And at the same time, they have to invest a lot to hire a data science team to actually have access to the state-of-the-art models. All right, so given all these issues, it's a good time to take a look at what we call this Web3. So in fact, Web3 is a very rough and very vague name people trendy use. So in fact, I would call it tokenized economy and collaborative intelligence, because that's the real essence of Web3 is about. Because I'm a data person, so I like to always think about Web3 from a data intelligence perspective, right? So if you look at the history, right? When we talk about Web 1.0, that's about bringing things from offline to online. So at least people all around the world can see things that originally is offline, right? So in this case, you can think about in terms of data, you are reading the internet, right? Ordinary user, you just read the internet. Then I clearly remember when I was in the US in my PhD days around year 2005. That's when YouTube was acquired by Google, right, with 1.6 billion US dollars. And from that moment onwards, we have this thing called Web 2.0, because every individual user like you and me, we can write internet, right? We can upload our personal videos online so that millions of people around the world can actually see our video. So people become crazy about it, because suddenly you feel that the whole world can enjoy whatever you generate. So that's why we call it user-generated content. And then because of this boom of UGC, because of this Web 2.0, then this big data becomes something really important for business. Because eventually business is about people, essentially, right? And why UGC is important? Because data now is closer to people's life. We are generating data about ourselves. It's no longer data about satellite, about road networks, or about genome data. It's about everybody's business, daily life. So that's why these data become so important for business. So that's why from year 2005 onwards, for the last 15 or 20 years, Web 2.0 has been the big push for the whole business world. But now, we actually encounter a dead end, because after so many years contributing our data, we realized that, wow, data is something valuable. And all these companies is benefiting hugely and profiting immensely from our data. But as the user who contribute the data, we don't get a single cent of that, right? So people start to realize that why this is the case. And Web 2.0 does not solve that problem. So that's why this notion of so-called Web 3.0 is proposed. The idea is that instead of just read and write, we care about ownership, so-called sovereign data. We want to give the data back to the user. And I would say the essence of Web 3.0 is really in this binding, so-called the data binding the identity with the data. So that's why the core component of Web 3.0 and this collaborative intelligence really goes down to these two pillars. One is about trust, one is about incentive. And in terms of trust, you can think about, essentially we're trying to use a cluster of Web3 technology, try to give trust both for the past and the future. Here is a way to think about it. If you look at the timeline, right? If you look at the point of now, what is about the trust about the past? Trust is about past is whatever that has happened, we can agree on that. That is something very hard in real life, because a lot of the problems in real life is because people cannot agree on what has happened, right? That's why we go to court, in business we have argument. So using Web3 technology, first of all, we can use technologies such as asymmetric encryption and hashing to establish what has actually happened, right? And then we can establish the unique pairing of entities. Now, this is an Achilles heel for human being for hundreds of years, because before this, it's very hard for us to prove ownership. How do you prove that you actually own something, right? How do you prove you own a physical item like a cup, a computer, or a house? And how do you prove the authorship? There are lots of things. If you go down to the root, it's about the unique pairing of two entities. And this is now achievable by technology without any reliance on the trustworthy third party, right? And then once this proof is established, we have technologies such as distributed ledger technology to make sure that this proof will be immutable. And this is really important, because if you have established something, but you cannot prove something is immutable, then there is no use, right? So that's why putting these together, this is about the trust about the past. We can always uniquely identify something has happened. What about the trust about the future? Trust about the future is really about if we agree on something, we'll make sure it will happen. And again, this is very hard in real life, because in real life, even if you have contract, if you have agreement, it's very hard to make sure that it will be enforced. But in Web3 world, right, based on smart contract, at least for on-chain data, right, for on-chain contract, we can make sure whenever something is triggered, it will be executed. That's one of the benefits of so-called these DeFi projects. And then we have other very important technologies for the trust pillar. For example, nowadays, we cannot talk about trust without privacy, right? So that's why things like zero knowledge proof, differential privacy, federated learning, these are some of the popular techniques now. And then if you're not feeling that your contribution has been fairly treated, then there is no trust. So that's why in terms of fairness, we have some very new topics on the frontier. For example, data pricing, right? Data and AI pricing. How do you decide how much you want to reward people for a piece of data they contribute, right? And then also we look at AI and data auditing. Now, this is different from financial auditing because we're looking at whether a model has actually used a piece of data for training. Okay, this is something that in the future we will have to use in terms of this when we actually establish data as an asset. Then on the other pillar, we need to look at incentive, right? Because with just the trust, it's not sustainable. Nobody is going to contribute if you don't have a good incentivization system. And in terms of incentive, these things are even less studied. For example, in terms of tokenomics, we need to look at market design, mechanism design, token design, and then we have lots of ecosystem things to go around it, right? So I would say there are lots of open problems, and in academia, many of these things are still open, right? At least in computer science. Now, back 2 years ago, we did a survey on so-called data pricing, and we surveyed around 200 papers. Most of them are from economics, not from computer science. So that means that we have to learn a lot from other disciplinary. Now, I want to quickly go through 3 examples to show you the idea of combining Web3 and AI. First is a national effort on fighting against the misinformation online. Now, we know that in Singapore, for the past few years, we really have a lot of cases where people have fake news, people have fraud things online, and then a lot of tragedies happen. So that's why the government is looking to how to combating so-called weaponization of internet. And this is a $20 million grant we recently got from MCI together with A-Star. So the idea is how to design a so-called a trust by design framework. Can you help to click? For the online trust. Now, we know that with the development of AIGC, it's now never before has been easier to come up with something fake nowadays, right? From text to pictures to videos, it's just simply too easy to create something almost near reality. But then we need to fight against that, right? And so if you analyze the whole process of the propagation of misinformation, we can see there is a stage of this formation of information, there is a propagation of the harm, and then there is a really consumption of the content. So you can mitigate and you can fight against this at different stages. Now, one way to think about is, of course, when you think about that, it's easy to think about we can detect fake things, right? But as we know, this is a never-ending game because the more powerful your algorithm to detect these fake things, the malicious user can actually use the same thing to create much better fake things, right? So that's why we have this, generative adversary network again. So instead of passively detecting things, can we adopt a more proactive approach to create and curate and circulate trustable information by design? So that's why in this proposal, we are trying to, in this ground call, we are actually releasing later this month, and I welcome you all to submit proposal. So it's really to come up with a more proactive way to fight against misinformation. For example, we can interfere in the different stages, in the intention stage, evaluation stage, and execution stage, right? And then technology we're looking at is, for example, we can adopt some source attribution technology, try to always be able to trace back to where the misinformation is first generated. And so we have trustworthy source, trustworthy network, trustworthy content. And then most of these are built on the Web3 technology, right? These are identity, data binding, content, provenance. And in fact, in industry, you have some examples of that. For example, there is a coalition for content provenance and authenticity project called C2PA. This is an effort from a few industry partners pulling together their technique to create a system where you can safely trace the origin of each piece of data, each piece of media, right? And for example, if you have an image that is created with, for example, this app called TruePic, right? The image is going to encode the camera information, the geolocation, the timestamp, and so on. And then if that picture is later modified with Photoshop, for example, right? And later it's actually edited with some other things and published as some media. Each step these operations will be encoded into the metadata, and those informations will be encoded by what they call a C2PA trust model, right? They have a trust model based on PKI, public key infrastructure. So this provenance data includes the metadata of original image, of a modification using all these things, and so on, right? So this is an example of nowadays the tool we have to fight against misinformation. The second example is recently we had a piece of work to make possible so-called this decentralized federal learning. Because nowadays, if you look at federal learning, in almost all the scenarios, we still have a centralized server to actually process all the parameters uploaded by the different nodes, right? And we argue that in the future, this is not going to be the most promising application, because if you have someone in dominant position, other business will not join. So if you want to have an open federal learning environment, then you have to really solve these challenges, right? First of all, how to train the model in a decentralized setting, in peer-to-peer communication. And then you have to consider presenting nodes, right? And that is the challenge we have. So the solution we propose is based on an adaptation of the proof of work mechanism together with an overlaying level of voting network using PBFT. So the idea is that we're leveraging the asynchronous nature of the proof of work so that large-scale applications can run independently, but we want to solve the finality problem, right? Because as we know, for proof of work, in theory, you never have the finality of the consensus. So you have to use an overlaying voting network to decide when to establish the epoch to lock down the consensus, and at the same time to decide upon the attribution of the benefits. But at the same time, because this is a federal learning environment, how do you make sure that when people claim this is the data they contribute, they are not lying, right? So we use a zero-knowledge technique called called privacy for peers, P4P. This is technology developed by Berkeley some years back, and the idea is that you ask people to deposit hashes of data before they actually submit their proof. And this way, when you actually verify the data, they cannot produce data on the fly, right? So this is the rough idea. Details, you can check the paper. The last one, I know we're running out of time, is really about one bottleneck of Singapore's data ecosystem. Because in Singapore, we have PDPA, and Europe, we have GDPR. So most of the SME here is in disadvantaged position because we don't have much data to use to know our customer. How do you make sure that local business, we can still get access to high quality data so that we can know our customer? Years back, World Economic Forum has published this white paper called Personal Data, Emerging New Asset Class. The idea is that in the future, our data, your data, my data, is just kind of like our money in the bank. They will be an asset we can use, we can deposit, we can pledge, we can earn interest from. So from a few years back, we started to work on this project called Symphony. And the idea is that we want to bring together data contributors, individuals like you and me, developers who contribute models, and data consumers who want to gain insight from the data. And then all these three parties will be united on this platform on the blockchain infrastructure. In interest time, I won't go into detail, but I want to just give you one example. I know some of you are using this app, for example, to measure how many steps you walk every day, right? Or how many steps you run every day. Now, if you think about such an app, it looks at your life from a very narrow angle, right? Just how many steps you walk every day. So if you talk to the owner of this app saying, hey, you know what, your data can be your asset, to them, this is really some nonsense because this small data is not going to be useful at all. Now, if this app joining this global data economy, then this small piece of data and combined with another 20 source of data, they might actually contribute to a model to say how much this person is interested in sports. And that label can be later maybe used by the insurance company to train a model to do dynamic pricing for your life insurance. And if the insurance company is willing to pay $10 for that model, for that label, and even that app only contributes 5% to the label, that 5% will be recorded on blockchain and they will be proportionally rewarded. So even this small app with their small piece of data will be proportionally rewarded by joining in this global data intelligence ecosystem. Okay, so I think that's pretty much I want to share. And like I said, the marriage between Web3 and AI is just the beginning, right? It's this not even the beginning, end of the beginning, but I would say this is the beginning of the beginning, right? So yeah, looking ahead, there are a lot of open problems in research as well as in application. Okay, thank you.
Okay, let's thank Professor Zhu for an excellent speech. Any questions from the audience?
Good question. That is actually cue for this slide. So, you know, I'm also wearing the hat as the Associate Dean for Partnership Engagement. So I feel obliged to show this slide. In SMU, we're trying to establish a center, just like in NTU, we have this Center for Computational Science for Finance. We're trying to focus on this domain of Web3, and we're focusing on these research pillars. So we have a whole stack of degree from undergrad to master to doctor to DBA even. So if you're interested, welcome to apply to a degree. At the same time, I would say it's really important nowadays to look at those open problems in the research domain that would combine AI and Web3. Now, just a few weeks ago, I attended ACM KDD in California. Many of the research topics are very interesting. For example, watermarking for AIGC content, and lots of interesting papers. So I would say, you know, as I said, there are lots of open and new important problems now. I think this is really a gold mine for you to dig into. Yeah. Okay.
Any other questions? Let's give some opportunity to students in the back seat. Any? No. Okay, that student again.
Hi, Professor. And I'm just a student here. I'm pretty interested in the application of AI. I see from your slide is that we can use AI to track like a fake information. So after the AI identify those fake information, and can people avoid that through the when they are using ChatGPT to generate a prompt?
Okay, so a quick answer. After we identify some fake information, how do we avoid them? Now, a quick question is that the goal, the thing we want to achieve is not try to avoid fake information, but trace back to the person who generated the fake information in the first place. Because think about in real life, why we don't want to commit crime, because there is a cost associated with that. We know the consequence, right? And instead of just fighting against the content generated by the malicious user, we will need to trace down to this user and then bind their data with identity so that they know the consequence when they try to generate these fake or misinformation. That's what we're trying to do. Right.
So you guys also trace back to the user who signed out those fake information.
The source is very important.
Prevent them to do it again.
Yeah, but person who helped to propagate, there are different cases, very complicated. Some people is just gullible, right? They're not really trying to on purpose disseminate those misinformation. But the source is usually, the problem, right? Yeah, okay. Okay, thank you.
Okay, now Q&A time is up. Let's give some applause to Professor Zhu for his excellent speech.